Hello, welcome another important video in our Solidity course. Here we are learning about different types of variables in Solidity. So learning about different types of variables in Solidity becomes important because transaction cost of each transaction, it depends on the variables. We'll see what is that in a moment. But here is the different types of variables in Solidity. One is state variables, which is nothing but the variables that gets stored permanently in a contract, and most of the times we make changes in permanent variables itself in order to make it available for others and do some important work in that particular contract. Then there is local variables, the variables that mostly not required outside of the functions that we declare in this local scope. And then another different type of variables is global variables, where these global variables provides us information regarding the blockchain and the contract related information. So we'll see each of this in one by one. So let's start with this state variables. So state variables we have already used in our previous video when we saw example of Hello World smart contract. So this is how the state variables looks like. We declare state variable as soon as we start contract scope. So state variables we can use whenever we want inside this contract. So as you can see, this variable is available in this function as well as this function. So we can change state variables as well as we can see information in that state variable inside this particular contract. Alright, so let me quickly compile this and let's see what is the difference between state variable and local variables. So let me delete our deployed contract, and our contract is already compiled. So if I use any other different account which has 100 Ethereum values, and if I deploy this, as you can see, some cost is deducted because every single deployment requires some gas fees to pay to the miners. So last 4 digits is 2933 at the moment. As soon as I make some changes inside the contract, let's say if I want to change this message, and for that we have this function which is state message, and as soon as I pass any value inside of it, it will change this state variable message. Alright, so if I see current last 4 digits for this Ethereum wallet is 2933, and if I send something and our transaction is completed, so we can see it here, some value from our wallet got deducted. Now this is because every time if we want to make some changes in our existing contract, so we have to pay some gas fees, and this gas fees is dependent on how many operations we are performing in that smart contract in order to complete the entire transaction. So if number of operations are high, so gas fees will be higher, right? So transaction cost is 30142 for our last transaction. So let's see this one more time. If I make a few more changes, if I set it, our transaction completed, and if I go back here and check again, from some value from our Ethereum wallet got deducted, and if we see gas fee or transaction cost for this time, it is again 30214. Now we know that whenever we make any changes inside the state variables, it is costing us some transaction fees. But what if we want to just see value and not to change the value? So in that case, will it cost transaction fee or not? So let's see this. So here is the get message method, and if I click on this, it will give me exact value inside this state variables. So now again I have requested this value, so will it cost us transaction fee or not? Let's demonstrate this as well. We have 2577 last 4 digits in our wallet, and if I click on this and go back here and see this, so our Ethereum balance is exact same. So now the question might have arisen in your mind, like why it is costing us fee when we want to make any changes inside the contract, and why it is not costing us any fee when we want to fetch this value. Now its answer is inside the entire operation of this blockchain. So this is the diagrammatic representation of how each transaction in Ethereum looks like. So let's say person A wants to send some money from his account, which is account A, into account B. So in that case, he will initiate new transaction request, and that transaction request will go inside the Ethereum blockchain. But by the time it will go inside the Ethereum blockchain, it will be in unconfirmed state. So in order to make it confirmed transaction, someone have to solve the complex mathematical operations in order to complete this transaction. So who will solve this problem? So those are the miners. Okay, so miners are those person who solve the complex mathematical operations in order to complete the transaction initiated by any particular user. So let's say user A initiated a transaction, it will go inside unconfirmed state pool, and miners will fetch that transaction and solve the mathematical problems. And once miner able to solve that mathematical operation, it will ask, or it will let other nodes know that okay, this transaction is completed. And if all nodes or majority of nodes will be agree on this block, they will add that block in actual blockchain. So this is how the entire transaction process works. So now the miners will not do it for free, because using their CPU power, their electricity, in order to solve your transaction, so they will have to get paid somehow. So in that case, we use this gas fees, which is getting deducted from each transaction. Now this transaction fees is depend on how many operations we are doing inside of each transaction. So if transaction is doing multiple operations, so it will cost much higher gas fees. And if transaction is simple, then it will cost less gas fees. So the basic thing we can keep in our mind that whenever we are making changes in a contract, we have to pay gas fees. Whenever we are not making any changes in a contract, we don't have to pay anything. Alright, so now let's have a look into other type of variables. Another type of variable which is local variable. And if we can see here, the variable value presents till function is executing. What does this mean is, well, in order to declare any local variable, we just make this, let's make a copy of this function. Let's rename this by message1, and we'll declare variable inside of the function instead of declaring it state variable. Let's change its name as well. Alright, so now we have one method which name is setMessage. Whatever we will pass as a parameter, it will get stored inside of this message1 variable. Now this is local variable, and if I try to use this message1 variable in this function, it will not be available. Alright, so it will get deleted as soon as this function executed successfully. So it is giving me error saying we need to declare this string memory type. So let's write memory. Okay, and again it is giving error saying we have to make this function as a pure function. So let's make it pure as well. Okay, so now there is no error, or code is compiled successfully. Let me deploy this. Okay, so if you can see here, we have one more setMessage function. So now if I change anything, it is working completely fine. So let's see the current last 4 digits in our wallet, which is 3279. And now we are making changes inside our contract again. And so now technically it should cost us some Ethereum values, and this value should get deducted from our account, right? So last 4 digits are 3279. So let me call this function. So it is completed successfully. And if I go back here and see, still there is no change inside the wallet. Still the value remains same, and this is because we are making change in our local variable, not the global variable. And this is the major difference between local variables and the state variables, right? So state variable changes will cost some Ethereum values, will cost some gas fees, while changes in local variable will not cost anything, because we are not making changes inside the contract. We are making changes in this particular function itself. So that is the major difference between local variables and state variables, right? So even though we make changes or we want to fetch values from the local variables, it will not cost anything. But if we want to make changes in state variables, it will cost some Ethereum values or some gas fees. So we just saw two different types of variables in the smart contracts. Okay, so now we need to make wise choices whenever we will write our actual Ethereum smart contract between local and state variables, because based on how we write our contract, it will decide the efficiency of that contract. All right, so let's move on to next type of variable, which is global variables. Now these global variables are those variables which gives us information regarding our blockchain and information regarding our contract. So let's see what is that. So here is the cheat sheet. Okay, so you will see here which type of variables or which type of values you can access from these global variables. So as you can see here, we have this base fees function through which we can check the current block fee, and then there is chain ID, there is Coinbase, and there is a lot more information we can fetch from the blockchain. Declare one more function and try to fetch its values. Okay, so now we don't need to make set method copy, we need to make get method copy, right? Because we want to fetch value. So now the return type will be unit unsigned integer, which is uint, and the return, which let's fetch this gas limit value. So let's paste this. All right, so now it is saying data location. Okay, so we don't need to make this as a memory. Okay, so now let's compile this again, and if I deploy it, our contract is deployed. Let me delete earlier one. Let's deploy it one more time, and if I, as you can see here, we have this global value function. Okay, so now if I click on this, we saw this gas limit value. So this is gas limit. Let's see what else we can fetch. So we can fetch block number. So this is nothing but whenever we make any changes inside the smart contracts, each change will be considered as a new block. So this block number will give us the current value of the block. Okay, so now we need to make compilation, and if I deploy it one more time, now let's see global value. So current block is 16. So now if I make any transaction and if I fetch value, so it will change. Okay, so now each time when I'm changing anything, new block will get added and block number will get increased, right? So this is the three different types of variables in the Solidity. And okay, so now we have better idea about different variables. This is slightly different than all other programming languages, because whenever we write any inefficient code in programming languages such as Java or JavaScript, it doesn't cost us direct money, right? But in Solidity, if we make any extra variable change, if we write any extra variable in our state variables, it will cost us gas fees each time. So that is the difference between different types of variables. I hope you have understood the entire concept. So I think that's it for this video. Thank you very much for watching. See you in the next video. Bye.